This is my poster on atypical motor movements in autism, an exploratory analysis using motion capture. As an introduction, atypical motor movements are a characteristic feature of autism affecting task execution and social integration. However, there is conflicting research on what specific motor differences occur in autism. Some results have longer movement duration, longer velocity, and other research has slower velocity and slower reaction times, and increased jerkiness and error correction. This also could relate to cerebellar variations that underpin motor differences in autism. Differences in grey matter could impact the coordination of people's movements. Yet, the current diagnostic criteria underrepresents motor differences in autism. It's very, very vague in the DSM as to what motor differences occur. We use motion capture to try and explore the differences between autistic and non-autistic people. This study is part of a 6-experiment PhD project into action kinematics. So what did we do? We did a between-group comparison of reach and grasp movements between autistic and non-autistic people. We're looking at motor coordination and velocity differences. Our participants consisted of 29 autistic and 30 autistic. They were recruited via voluntary sampling. Materials used was Codamotion motion tracking software with 9 thermal imaging cameras and 14 nodes placed on key anatomical landmarks. Our procedure: participants sat down, had the equipment attached to them, and then they were asked to pick up and move an object a number of times. We had one block which was standard reaches, so they're just reaching for an object and bringing it back to them, and then putting it back again. And then block 2, an overreach, where they're navigating an object, so they're reaching over a different object to retrieve their cup. For our results, our motions were segmented into 4 phases: the reaching, retrieving, returning the cup back to the start, and resetting. You can see here a depiction of a standard reach and then an overreach for the 2 blocks. And we can see here the dotted line for autistic and the solid line for non-autistic. So we had 60 trials, 13 each block, split into 2 sets of 15. We were then reporting any findings that replicate for both of these splits. For our first block, we found no significant findings for the means or the standard deviations. And for block 2, our overreach findings, we found a bunch of significant results. More particularly in our third phase, when they are holding their cup and then navigating an object to come back again. This is a more complex cognitive task. It requires more coordination. So we found that peak vertical velocity was different, the percentage of peak vertical velocity, the time of peak vertical velocity, and forward velocity as well. And you can see these indicated here on these graphs. We've got the mean standard deviations, the second order standard deviations, and you can see that they are higher in the autistic group. For our discussion, our key findings show that increased variability of motor differences between autistic and non-autistic groups. Group variations in, as I say, peak vertical velocity, the time of forward velocity and horizontal amplitude, and these again, they replicated in alternating trials. So what can we interpret from this? This suggests distinct patterns of goal-directed motor control. The standard deviation versus the mean, why do we use the standard deviation, is because it highlights variability within these groups rather than just the averages, which might indicate why some studies in the past didn't find any differences, or they found conflicting research. Now, these movements are complex cognitive tasks. Significantly different differences noticed in phase 3, where navigating a different object requires more cognitive control than standard reaches. This is more demanding on our motor coordination, which is different in autistic groups. What can we apply from this? Kinematic differences align with previous findings regarding cerebellar atypicalities in autism, and it also suggests that motion capture could serve as a non-invasive method to assess motor coordination. For future investigations, the data from this is still being analysed. We're looking at grip aperture and wrist orientation for these groups as well. And further experiments are being investigated as to whether this impacts our perception of other people's behaviour. Can autistic people predict other autistic people easier? And same again for neuro-incongruent dyads. If you want to find out more, please check out my website right here. Thank you.